So transistors are semiconductor devices that can turn on electronic devices, so like this light bulb, or amplify an existing power source, like this transistor is doing right here. So the transistors are commonly made out of elements like germanium, gallium, and most prominently electronic devices, silicon. So semiconductor means that it's not much strongest conductor as copper, but it's not much insulator as air. So that means it will go through, but only after a certain amount is met.
Intrinsic semiconductors like pure silicon and germanium aren't as useful on their own as their function depends on temperature. So to increase their conductive capabilities, impurity atoms are integrated into the lattice structures of these elements. Depending on the type of impurity atom added through a process called doping, an N-type semiconductor or a P-type semiconductor is created.
An N-type semiconductor is created when a prevalent element such as phosphorus, arsenic, or antimony is added. The extra electrons provided by these impurity atoms increases the conductivity of these semiconductors. A P-type semiconductor, on the other hand, is created when a trivalent atom, such as boron, aluminum, or indium, takes the place of an original semiconductor atom. The lack of electrons, called holes, and apparent positive charge is what results in the increased conductivity of a P-type semiconductor. The combination of these semiconductors in an NPN or PNP form is what makes a transistor. So a certain amount of voltage goes into it, electrons in the N regions flow to the P regions and vice versa, allowing it to turn on or amplify the existing voltage.
A plasma is a type of gas in which a significant percentage of the atoms or molecules are ionized. Our plan is to use plasma-enhanced chemical vapor deposition to make carbon nanotube transistors. Catalytic metals such as iron, nickel, and cobalt are used on a substrate such as silicon or silicon dioxide using chemical vapor deposition. CVD is a process used to produce high-quality, high-performance solid materials. After the nanoscopic fine metal particles are formed, the carbon nanotubes grow on the metal particles on the substrate by the plasma discharge generated from a high-frequency power source. The advantages of using CNT transistors is that they are much better conductors of heat and can operate at much higher temperatures than traditional transistors. They also provide better electron mobility, are chemically inert, and provide higher output than traditional transistors for the same input.
The biggest disadvantages of carbon nanotubes is that currently no technology exists for their mass production and high production costs. Another issue is that smaller transistors require smaller contacts, and shrinking those contacts shoots up resistance. However, that problem has recently been solved using molybdenum contacts that have been chemically bonded to the CNTs. Further shrinking of the transistors will cause more problems like quantum tunneling that we are not equipped to deal with. The raw materials required for building CNT transistors like silicon and carbon are abundant in nature. The processing and fabrication costs, however, are extremely high. The device fabrication is already in the prototyping phase, but large-scale implementation is still an issue. Plasma-enhanced chemical vapor disposition is seen as a viable method because it can theoretically be integrated into the production process with just a few extra steps.
Next up, we're going to talk about some courses that are important in plasma use in semiconductor manufacturing. One in particular for ECE is ECE 444. This is called Integrated Circuit Theory and Fabrication. It's a lab course that focuses on design of integrated circuitry and electrical properties of semiconductors and transistors. Next on to the NPRE courses, there's a couple important ones, but in particular NPRE 429 is plasma engineering, where you focus on adapting plasma state to solve engineering problems such as plasma processing and microelectronics, and NPRE 421, which is plasma infusion science, and it introduces the physics of plasmas and problems such as confinement. And onto the material science and engineering courses such as MSE 460. This course is called Electronic Materials and Processes. It introduces material science and processing of semiconductors, including their structure, their chemistry, and some processing challenges faced by them.